So to the question about your favorite analogy, I briefly did an oil and gas consulting project in between jobs in the past, and it was during that very short project that I learned about actual oil pipelines, and I was shocked at how good the analogy is. I used the analogy before and kind of liked it in general, but learning about mechanically how pipelines actually work, it's hilarious the degree of similarity there is between an ETL system, a data warehouse, and storage for oil. So that was a fascinating project. I have a question before I get started. Who's taken an Uber before? Okay, pretty good. I see who the Lyft users are. I may have written a data pipeline that your data's moved through in the past. Before starting the company that I'm at now, I worked on the data platform team at Uber. When I joined, the company was around 200 employees. We had Postgres databases, not much else. There was no data warehouse. There was no data lake. We had probably fewer than 100 data sets at the company. When I left in 2018, we had more like 10,000 employees. Around a third of those were working with our data platform in some capacity each week. We had around 100,000 tables, and that was around 200 petabytes of data when I left. So it was a very interesting time to watch the data platform grow from having maybe 50 internal users on it, including myself, up to needing to serve several thousand people. And this is a globally distributed team, obviously, due to their business model. So what I wanted to talk about today is sort of this renaissance that's going on right now in data engineering. And I had the privilege of watching a version of that develop internally at this company during the 6 years that I was there, largely due to the degree of investment. I think, like someone said up here, the CEO of that company was incredibly bought in to how important data was to that company's success, to the degree that there was budget and there was headcount available to basically go and build whatever data tooling we needed to keep up with the company's growth. And so what that led to was the opportunity to develop a lot of internal tools and practices for managing data basically from scratch, which has pros and cons. I don't know if it's the greatest use of company funds, but that is what we decided to do. And what it led to was borrowing a lot of concepts from our friends on the infrastructure and the software engineering teams. We had questions about, I think data ownership came up in the last conversation. That was a huge problem. We had 100,000 tables. Who owns each table? Somebody else writes an ETL job on that. Does that change the ownership? How does that work? What does the lineage look like? Where is the data being used around the company? How do we decide when we have a problem in a pipeline? Does somebody need to wake up at 3 in the morning, or does it go into a backlog and we can fix it in 2 weeks? So to deal with a lot of those challenges, we looked at things that were going on the DevOps side of the company. So we looked at having SLAs for our data pipelines. We looked at making sure we had on-call rotations. We had well-documented severity levels. So we could say this particular problem in a pipeline is a Sev 5 or it's a Sev 1 based on what impact it has around the company. What are the expectations when a data engineer is addressing a problem in a pipeline? How often do they need to provide updates? Who's responsible for liaising those updates out to the business? So we found a lot of success in adopting those patterns from DevOps. And that led to me leaving Uber later and starting my company that I'm at today. But I've been seeing these same parallels that we went through within Uber happening externally in the market in a larger fashion, and that's what I wanted to talk about. So does anybody know when Git and AWS first became publicly available? What year? 2002. How about, so Puppet is Software Configuration Management Framework, 2005. And Datadog, very popular observability system, 2010. Now, if we flip that and we go to the data side of things, when did Snowflake get founded? 2012. Exactly 10 years after AWS debuted. Snowflake is effectively the equivalent of EC2, but for data teams, right? It's elastic compute for your data warehouse instead of elastic compute for your software engineering teams. Airflow, a framework for managing the configuration of your data pipelines, 2015. Almost exactly 10 years after Puppet in 2005. And then my company and several of our competitors in the observability space, specifically for data teams, to help them understand what data systems do we have, how's the data flowing through them, what does the lineage look like, when do we have problems, and how do we run an incident management process around them. 2020 is when my company was founded, exactly 10 years after Datadog. So over the last 4 years, we've seen that trend pushed basically to the limit with around $1 trillion of venture capital funding coming into the overall IT software space. And that's across, I think, 100,000 total deals over the last 4 years or so, according to PitchBook. So there's been massive, massive investment in further accelerating that trend. And a huge chunk of that, well, that's broadly for IT software, huge component of it obviously going into specifically data companies, machine learning, ML ops, data ops, et cetera. So we're seeing demand for that, and we're seeing VC funding causing an explosion of the availability of data tools available for data teams. And I believe that's only going to accelerate that trend even further. So I got to watch within one company the importance of scaling up the way we manage data using these DevOps principles, and we're seeing it now happen also in the broader market with the tools that are available. So the conclusion that I'd want you to take away from the talk today is really that if you're looking at scaling data governance, data management, data operations, I suggest that you look to the processes and the tools and the frameworks that are already working on what I assume are your fairly well-established DevOps practices, your infrastructure teams, your software engineering teams. And when we're looking at solving data problems, that may not be the first place that we think to look to. But I strongly recommend that you do that and you look at what is working in keeping your software reliable and keeping your infrastructure reliable, in setting SLAs and delivering those SLAs, and how much of those practices can we copy in the world of data without having to reinvent the wheel. I've seen at least one case of it working very well. I think there's going to be many other good success cases out there as well. So that's the thought I'll leave you with today. If you're looking at scaling data, I suggest that you look at what's been going on in DevOps over the last decade and see if there's any good practices there that you can borrow. Thanks.